Hi everyone. So today's problem is maximum matrix sum. So here's the problem statement. We are given an n% integer matrix, and what we can do is we can perform one following operation any number of times. Say for example, we can choose any two adjacent elements in the matrix and multiply each of them by -1. So here I have an example. I have selected this group, multiplied with -1. I've got this. Then I have selected vertically and finally got this entire positive matrix, right? So initially this matrix sum was 0 and this is 4, right? So what I need to do is somehow be able to maximize this sum of matrix. So yes, as you can see the description over here, our goal is to maximize the summation of matrix elements. So here I have taken another example. Here now I have three elements in the matrix, three negative elements in the matrix, but I have chosen this group. I multiplied with -1. And what I've been able to do is I've been able to convert -2 and -3 into +2 and +3. So yes, I could have done it with -1 also, but that would haven't been that maximum, right? So what matters? So one observation I would say is we need to somehow get absolute values, right? So yeah, here's the explanation. We can follow the following same steps as previous one. Okay, so let me just break down the intuition quickly. So, on seeing this problem, what we might feel is this might be a recursion of greedy problem. So, by recursion, what I actually mean is, and this could have been dynamic programming problem. Like it feels like there are some overlapping subproblems, but there aren't. So, what we are left with is greedy. So, I've taken an example to build some intuition. Here, there are two negative elements only in the matrix. -1, -3. Rest all are some positive numbers. So what we can do here is we can finally convert this into both +1 and +3. Because say for example, we group this will become negative, this will become positive. Then later I can group this, so this will become minus. So I can group it irrespective of the distance, right? And finally on grouping here, these both these both would get converted into positives. So basically what I'm trying to prove is irrespective of the distance, what matters is the number of negatives. Here's what I've written once again. So what matters is the number of negatives rather than the distance. So here I have one more example. So -1 could have been compensated with -2. So here's another example. -1 can be compensated with -3, -2 with -1, -1 with -4, and -2 with -3. So as you can see, the number of negatives here are 8, right? The number of negatives here are 8. So one observation is if the number of negatives are even, we can take the absolute sum. But what if it was odd, right? Say, for example, this was -4. Then this would have been left out, right? So what could have been done instead was we could have compensated with the least negative value, least absolute value, right? So in short, if even there is no problem, but if odd, we need to compensate it with the least absolute value. So here, what if? So here I have taken one small edge case also. Basically, here number of negatives is 3. So -1 could have been compensated with -2. And we might think, oh, -1 is left out. But actually, we could have made a group of these both and still obtained a perfect answer. So in short, if there are negatives also, like if there are odd number of negatives also, it can be still fine if there is at least one zero in the matrix. So here's the code I have written. Since the sum can be overflowing, they have taken long. It's fine. So here I'm traversing the matrix. I'm checking if I'm counting the number of negatives. And here I'm checking if there is at least one zero in the matrix. And I'm also calculating entire absolute sum simultaneously. And of course, I'm calculating the least absolute value. So if it is odd, then this is my logic. If it is even, then I can just simply return the absolute sum. If it were odd, then I'm making a further inner check whether it contains at least one zero. If true, then I can just return the absolute sum. Otherwise, what I can do is I can remove two times the least to absolute value. So just to explain what this part is, here in this matrix, say for example, the least absolute value is -1. So it's actually so the least negative number is -1 and its absolute is +1, right? So what actually happens is in the absolute sum, we are adding by mistakenly +1 when instead it should have been -1. That should have been added instead. So what I'm doing is I can subtract minus of that 1, but then I again need to add -1 for the final sum, right? So instead what I can do is I can just simply multiply with -2 times. So yes, that is that. And I hope you have understood the entire logic overall. Thank you so much for watching the video then.